All right, we're going to be looking at the 5.1 practice quiz, and I'm not going to work every single question, but I am going to work what I think is probably the harder ones or the ones you guys might not remember. Remember, if you take notes, you can use the notes from the practice quiz on the quiz tomorrow. So, here we go. This practice quiz starts with this picture right here, which this is like a version of, you can't see that. This is a version of what we built in class, right? This would have been our orange piece of paper. The figure, this would have been our orange piece of paper. And then the line through it, this would have been our pencil going through the paper. And L here would be the line that we drew on the paper. So, question 1 says, give 3 names for line L. And from your notes, hopefully you're referencing them as you're going through this. To name a line, we use any 2 points on that line. Any 2 points on that line. So, looking at this picture, I see the points R, Q, and S. So, here's line L. And so if I want to name it, I just pick any 2 points. RQ, QS, RS, those would be the 3, okay? And remember when we draw them, because we're talking about a line, we have the notation with the arrows on the top. So RQ, QS, and then also RS would be 3 names for that line. Question 2 says, give 3 names for the plane. So again, if we're referencing our notes, which hopefully we are, we're going to be able to see that we can name a plane given any 3 points on that plane. I'm sorry, I'm trying to adjust the lighting here, and I can't seem to find my remote. So 3 points on the plane, not on the same line. So by that, I mean not on line L. So I can't choose RQS because RQS are not, or are on the same line. So any other variation of 3 points on the plane, okay, I'm about to give up on this, it is perfectly fine. So, let's see what that, here we go. All right, I'm back. So, for example, here are the points on the plane. Remember, P doesn't have a dot by it, so it's just the name of the plane. So, V, R, Q, S, those are all points on the plane, okay? So, I could do, for example, V, R, Q. So, 3 points together, no commas between them. Or V, Q, S. Or RVS. So 3 points on the plane, not on the same line. Okay? Question 3 says, name 2 points not on plane P. 2 points not on plane P. So again, remember, this line right here, I'm sorry, the lighting is terrible today. This line right here is the one that would be through the plane. And so when I'm looking at it, I'm just going to find points on that line. So for example, N is below the plane and T is above the plane. So we would have like point N and point T as points not on the plane. 4 says opposite rays. So remember, rays are 1 point, 1 arrow, 1 endpoint, 1 arrow. And if I have opposite rays, we share the same endpoint and they go in opposite directions, right? So let's say we're talking about the point Q as the point they share. So QR would be 1 ray. And remember notation, 1 endpoint, 1 arrow. So that would go this direction. So to do opposite that, I would just do QS, which would go this direction. So QR and QS are opposite rays. And it says 2 pairs. I'm going to switch colors here. So if I still do Q, but I want to go through the plane, I could do QS QN as one ray. So I'm not saying that QN is opposite QS, okay? I'm not saying that. And then opposite QN would be QT. So QN and QT would be opposite from each other because they create an entire line. Number 5 says, name a line that intersects plane P. So again, that's that what is now the blue line. Because of the dotting, that tells us that it's going through the plane. And so that would be line TQ, or I could have named it QN, or I could have named it TN. I could have named it any one of those three things, okay? Number 6 says, name a line contained on P. So that's the solid line in pink. That's that solid line in pink. So lots of names for that. I'm going to be lazy and just say L because we already named L a bunch of ways up here. And then 3 collinear points. Remember, collinear means on the same line. Collinear means on the same line. So you have 2 options here. You can do the pink option, which would be RQS. Or you can do the blue option here, which would be TQN. And because they're points, that's why I'm putting commas between them now. And then number 8 says, name 2 points that are not coplanar. Not coplanar. That means they are not on the same plane. So pick any point on the plane and any point off the plane, and they are not coplanar. For example, R is on the plane and N is off the plane. So those would be 2 planes. I could have done S and T, R and T. There are a lot of options here that I could have done. Okay. All right, the next thing we're looking at is 5.2, which is what we spent the majority of our time in. So we're looking first at use a number line to answer the question. So remember, if I have dB, what I'm actually looking for is the distance from D to B, or the length of dB. And I can find that by taking the absolute value of D minus B. Okay, by finding the absolute value of D minus B. And so I'm just going to get a sticky note here so that I can work this problem. You may want to get on a separate sheet of paper at this point because there's really not enough room. So D to B, if I look at point D is at -2, right? So this is going to equal -2. I'm just replacing D with -2 right now, minus B. And B is at -0.5. It's halfway between 0 and -1. Let me go in just a little bit. Halfway between 0 and -1. So I'm going to have -2 minus -0.5. That is all the negatives. I meant for that to be a vertical bar. Okay. So minus a negative, I'm just going to do -2 plus 0.5. And if you are somebody who struggles with positives and negatives, then go ahead and use a calculator, okay? So -2 plus 0.5 is going to be -1.5. And then the absolute value of -1.5 is 1.5. Right, so this would be my final answer. And I, of course, can count that if I count from D to B. So here's 1, and then here's 1/2, because you're not going a whole another unit, right? I'm not going to do all of those. I think those are pretty self-explanatory. You're literally just subtracting and then taking the absolute value in every single case, right? And then point or number 6 says find the midpoint of DA. Find the midpoint of DA. And so what I want to remember about the midpoint is I'm just add and divide by 2. And we've done this a ton. So I would just do D plus A and divide by 2. Okay. So I know D is -2. And I know A is at 3. And -2 plus 3 is 1. And so what I have here is 1 over 2. And I can leave it as a half, or if you prefer a decimal, you can go all the way to a decimal. And then I just really kind of want to check to make sure that even makes sense. So what I'm going to do with this midpoint of DA thing is I'm just going to go to my number line and put a point at 0.5, and I can actually just count to see if that's really the midpoint. So from A, it's 1, 2 and a half. And from D, it's 1, 2 and a half. So that's how I know it's the midpoint. So let's actually do that again. Let's do AC this time. I think you can actually just see AC as 4, but of course you know I like to see the work. So if I want to find the midpoint of AC, I'm just going to put a squiggle here, then I would do A plus C divided by 2. A plus C divided by 2. So A is at 3, and C is at 5, and I divide by 2. And 3 plus 5 is 8, and 8 divided by 2 is 4. And if I just check 4 really quick, I'm trying to see if 4 really is the midpoint between A and C. Well, it's 1 unit from here and 1 unit from here, so I know I have the right answer. Okay. All right, I'm going to leave 8 for you to do because that's pretty self-explanatory now. Questions 9, 10, and 11, you're comparing. So by compare, that means you're going to use a less than symbol, a greater than symbol, or an equal to symbol. So I would just find the length of DB, find the length of BA, and then decide less than, greater than, or equal to, right? So we actually already did DB, and we decided that that DB length was 1.5. And we haven't done BA, but we can probably come over here and count it, right? So it's a half. We're going B to A. It's 1/2, or 0.5, 1.5, 2.5, 3.5. But you would have already found it up here. So BA is 3.5, and 1.5 is less than 3.5. So I would just compare using a less than symbol. One more like that. We just found that BA is 3.5. So I'm going to come up here and look at AC. If I count AC, 1, 2. From A to C is 2 units. 3.5 is larger than 2, so on this one I would use the greater than symbol. Remember that if you learned the alligator trick, that if this is an alligator's mouth, it's always eating the bigger number, right? So it's like, I'm not an artist, but wow, he just doesn't look good at all. What do they have? Big long tail. Something like that. Right. Always eats the larger number. Okay, you're welcome for that wonderful art. Moving on to the next section, which I think you guys really did the best on. So I'm not just going to spend a ton of time here. So in this case, each piece, you're looking for the missing value. So, for example, in this one right here, we're looking for GE. We're looking for GE, which is all of this. Well, I know 8, but I don't know what GF is, but I do know that this is 6, right? So I can say, okay, but I know that HG plus GF is equal to HF. And I know HG is 3, and I have to find GF. And I know that HF is 6. So I can just subtract 3 to get GF, right? 6 minus 3 is 3. That was gone. So now I know that that's also 3, so they're actually equal segments. But remember, you always want to actually answer the question, So GE is equal to GF plus FE, which is going to be 3 plus 8. So GE is 8, 9, 10, 11. So these are all like that, and I think you can reference your notes in order to get through those. If not, you can always show up early tomorrow for, well, I have tutoring in the morning, but you can always ask me first part of class, and I'll help you if there's one you got stuck on. 17, 18, 19, and 20, you have to draw your own picture. And so I'm just going to randomly pick one. I'm going to move to a piece of paper. So, for example, if we were to work 18, it says find BC if AC is 5, AD is 11, and BD is 9. Okay. Let's see here. And I didn't tell you what order to put these in, so I'm going to put them in alphabetical order. Points A, B, C, D on a line. And it says find BC. So this is the one we're looking for. If AC is 5, AD is 11, and BD is 9. All right, so remember what we're looking for here. So I always try to think about, like, what do I have all of and what can I take away, right? So if I know the whole line segment is 11, and I were to take the 5 away from the 11, that would leave me this part. If I take this 5 away from 11, that leaves me this part, which is CD. So I can find CD by subtracting 11 minus 5, or AD minus AC. So I know CD has to be 6. And I can do the same thing here. I know the whole thing is 11. I know B to D is 9. So this time if I take 9 away from this 11, then it leaves me with this part, right, which is A to B. So I can find AB by taking all of 11 and taking away 9 this time, right, which is AD minus 9, which is BD. And so AB ends up being 9, 10, 11, 2. Okay, so now I know this is 2. And now I can use the fact that AB plus, let me move this here, AB plus BC plus CD has to be the whole line segment AD. And I just solved for AB. I found out it was 2. And BC is what I'm actually looking for. And I solved for CD. It was 6. And I was given AD, the whole line segment. It was 11. Right? So now I can combine like terms over here. And BC plus 8 has to be 11. So when I subtract, I get BC is equal to 2, 8, 9, 10, 11. I can't subtract today. So that gives me BC is 3. Right? So that's that section. Make sure you make your picture and really think about what's happening in that scenario. Questions 21 through 28 are the variable problems that we looked at in class today. So we're going to work a couple of those here. If I'm working one that already has the picture drawn, then let's say even if we just start with 21, it's pretty straightforward. What I'm going to do is I'm going to say, okay, I know that this piece plus this piece has to equal the whole line segment, which is 4x minus 3. Okay. So in this section, we're just going to be solving for x. Just solve for x. Okay. So, and you should be able to see this a little clearer on your paper. I don't know why the light is just bad today. All right. So number 21, I say small plus small equals the entire thing. So x plus 4 plus 2 is equal to 4x minus 3. So what that was uv plus vw is equal to uw. That's where that just came from. Okay. And then from there, once you have the equation set up, then it's pretty easy. So I'm going to do that thing where I organize my space. So I'm going to put a line through the equal sign to keep me organized. And then I'm going to look for like terms. So right here we can see I have a positive 4 and a positive 2. I'm going to be able to combine those together. So I have x plus 6 is equal to 4x minus 3. And then the next step is to get x on one side of the equal sign. I usually like to not subtract necessarily, but to move the smaller one so that I don't end up with negatives. So I have a 1x and a 4x. So I'm going to take this 1x away from this 4x. So I subtract 1x from each side of the equal sign. 1x minus 1x is 0. That's exactly what I want to happen. I want it to go away from one side. I bring down the 6. 4x minus 1x is 3x minus 3. Now, it is in our nature to want to keep moving stuff to the right. But we're trying to get x on one side and numbers on the other side. So I don't want to move this 6 over here. I'm going to move this negative 3 over here. So I add 3 to both sides. 6 plus 3 is 9. Bring down the 3x. Negative 3 and positive 3 goes to 0 like I want it to. And then just one more step, because I'm just solving for x, is just to divide by 3. So for this problem, x is equal to 3 as my final. Let's do that one more time. So we're going to look at 24. I know I've kind of been not working more than one for each kind, but we're going to do that again because I know some people kind of struggle with this, the equation part of this. Okay, so for 24, I'm going to say small plus small equals entire piece. So TU plus UV is going to be equal to TV, the entire thing. And TU is 8, and UV is 2x plus 1, and TV is 12x minus 1. Right. So once I have it set up, then I just want to solve the little equation. So I'm just going to organize my space by drawing this line. The line's not necessary. It just kind of helps you get organized. All right, looking for like terms again, I notice that I can combine 8 and 1. So I get 2x plus 9 is equal to 12x minus 1. So the same thing's about to happen here. I have 2x on this side and a 12x here on this side, and I only want x on one side, and I usually move the smaller one. So again, I'm going to the right. I'm going to get rid of 2x from this side. Right, so 2x minus 2x is 0, exactly what I want. Bring down the 9, nothing's affecting it. 12x minus 2x is 10x, bring down the minus 1. And again, we really just, so many people want to keep going to the right, but we want numbers on one side, x on the other. So I'm actually going to move this negative 1 over by adding 1 to both sides of the equal sign. 9 plus 1 is 10. Bring down the 10x. Negative 1 and positive 1, that's 0 exactly like I want it to be. And then divide by 10. divide by 10, and I get 1 equals 1x, or just x, just like that. Okay? One more section, and I'm kind of running longer than I had hoped, but one more section, 25 through 28. Again, we have to draw our own picture, but actually one step further than that, we're not just looking for x in these cases, we're looking for a specific length or a specific segment. So this is the one that takes one extra step. So let's just work, well, we'll just start at the beginning. We'll work 25, right? So 25 says, find AC if AC equals 12x, BC equals 5x, and AB equals 7. And again, let's just do them alphabetical order. So I'm going to draw my picture. I'm always going to draw my picture because that's how I am. I like visuals. So I'm looking for AC, which is the entire thing. If AC is 12x, BC, which is this part, BC is 5x, and AB is 7. And remember what I want. I want to know, what does BC equal? No, I don't. I want to know, what does AC equal? See, told you. Go back and read, and read, and read, and read, to make sure you're actually answering the question. Okay. From there, I can set up my equation, because I know that AB plus BC equals the entire thing AC. So 7 plus 5x equals the whole thing, which is 12x. All right. This one's strangely hard for people, even though it seems like a shorter problem, because of that 12x issue over there. Okay? So, let me organize, organize, organize. I don't have any like terms to combine. All right? 7 and 5x don't combine. You might be tempted to add 5x and 12x, but you can't do that because they're on opposite sides of the equal sign, which is why I like the line to help us organize. So I'm going to move the smaller x using subtraction. So minus 5x from both sides. Nothing's affecting the 7, but a 5x minus 5x is going to 0. So I bring down the 7. 12x minus 5x is 7x. And easy, one more step, 7. So x is 1. But this is where you have to be careful, because this is not the last step. Go back to what the question is asking. It's asking for AC. And AC is actually 12 times x. And x is 1. So AC is going to be 12 times 1, or 12. So answer the question that's being asked. All right, I'm going to stop there because that has gone on and on and on and on. If you have any more questions, please ask them at the beginning of class tomorrow. I would love to help you before we quiz. Good luck, and I'll see you tomorrow.